மேம் மேம் வாய்ஸ் கேட்கல மேம்.
எவ்வளவு நேரமா கேட்கலாமா? இப்ப கேக்குதா?
எஸ் மேம்.
எவ்வளவு நேரமா கேட்கல திவ்யா? திவ்யா நான் பேசுறது கேக்குதா?
கேக்குது மேம்.
எவ்வளவு நேரமா கேட்கல?
இப்பதான் கொஞ்ச நேரம் தான் மேம்.
சரி, அதுக்குதான் ஏதாவது ரெஸ்பான்ஸ் பண்ணும். நான் பேசுறது ஏதாவது கேக்குதா கேக்குதான்னு கத்துறேன்ல, அப்பதான் ரெஸ்பான்ஸ் பண்ணும். அப்படியே இருந்தீங்கன்னா எனக்கு தெரியாது. யாராவது இப்ப நீ இந்த மாதிரி ஏதாவது சொன்னதான் எனக்கு தெரியும். எப்படி எனக்கு தெரியும்? எவ்வளவு நேரமா கத்துறேன் கேக்குதா 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 கேக்குதான்ட்டு. இனிமேல் நீ நான் கேட்கறப்ப நீ பதில் சொல்ல அப்படின்னா நான் கிளாஸ் எடுக்க மாட்டேன். நீ போய் எங்கேயோ படிச்சுக்கோ, எப்படியோ படிச்சுக்கோ. தூங்குவியா எல்லாம் ஆன் பண்ணி வச்சுட்டு? Next, I'll be having two approaches for hardware multi-threading. What have you seen? We have seen what is this multi-threading and hardware multi-threading. What is this thread and what is this thread switch and what is the processor? Multi-threading அப்படின்னா I'll divide the entire instruction streams into small instruction streams and then I'll process several small streams parallel. All the small streams will be executed parallelly. This process is called multi-threading. What is this hardware multi-threading அப்படின்னா, here what I'll do, I'll be having a processor. I'll use this processor effectively. That is, our processor is an hardware or a software. Processor is an hardware and your OS will be the software. So I'll use this processor repeatedly. Then one thread is completed, I'll go for the second thread and I'll keep changing the thread once it is getting completed. For that, I have to know what are these threads present in this stall. Once I know the data is present in this stall, I have to see that and then I have to start the process. Next, thread is nothing but this will include a program counter, or it can be a stack or a register. That is, here normally this thread will be sharing the same address location. Same address location will be there, but the data present in it alone will keep on changing. That is, here the processor does not change, only the data present in it will keep on change. Okay. Next, what is this thread switch abdina? If one thread is completed, I have to go to the switch to the second thread to get completed. That is called process switch. What is this process? This process includes, will be including two or more threads. Here I'll be having a two or more threads. Now what I'm doing is, in this process I'll be having an operating system. This operating system, using this operating system, I'll keep processing these threads. Once one thread is completed, what I have to do, I need not change the thread, I have to change the processor. Okay. So this operating system, what it will do, it will go check the processor and it will process the data and to provide the output. If that is happen abdina, I need not change the thread, I have to shift the processor. Okay va? What is this multi-threading? It will be having several processor. So over processor it has to keep changing. That is called process. Then here I'm having two approaches of hardware multi-threading. That is two main approaches. What is the two main approach? That is fine grain multi-threading. Another one is coarse grain multi-threading. In fine grain multi-threading, here I'll be having a version of hardware multi-threading. That is, that this will imply switching between the threads after every instruction, resulting in interleaved execution of multiple threads. It switches from one thread to the another at each clock cycle. Okay va? This is a version of hardware multi-threading. That is, what I'll do, I'll be having a processor. In what is hardware multi-threading? I'll be having a processor. Once the one thread is getting completed, I'll keep on switching the threads. This is the process. So in this fine grain multi-threading is same as your hardware multi-threading. So at every instruction, or instruction if the result is obtained abdina, I'll go for the next instruction. So that what I'll do, I'll be executing multiple threads. Multiple threads will be executed. Okay, over clock cycle, at each clock cycle one thread will be completed, and the next clock cycle another thread will be uh, will be processed to get complete. புரியுதா? This fine grain multi-threading, what I'm doing, I'll be having a uh, processor. Here, this processor, what it will do, once the one thread output is provided, it will keep shifting to the next thread. So, in the process of at each clock cycle, there will be a switch in your thread. That is, the switches it switches from one thread to the another at every clock cycle. This interleaving is often done in round robin fashion. எப்படி இதை பண்றோம் அப்படின்னா in round robin fashion. What is round robin fashion அப்படின்னா whatever data who are the participants those are present in it will get the chance in a round basis. ஓகேவா? அப்படி இப்படி ரவுண்டா கிடைக்கும். That is all the participants will get the chance. That is the main concept here. Okay. Next, skipping any threads that are stalled at the clock cycle. What I'll do அப்படின்னா here I'll not skip any data and then I'll keep processing all the data. Next, this to, to make it practical, that is to make this fine grain multi-threading practical, what we have to do, the processor must be able to switch thread on every clock cycle. On every clock cycle, it should have a capability of switching the thread from one thread to another thread. It has to keep on switching. Clear? This is the processor. That is, to make fine grain multi-thread practical, the processor must have the capability of switching from one thread to another thread on every clock cycle. What is the advantages here is, here vertical waste is eliminated. Any vertical waste, that is time, ஒரு ஸ்விட்ச்ல இருந்து இன்னொரு ஸ்விட்ச் மாத்துறப்போ அந்த மாதிரி அங்க யூஸ் ஆகுற அந்த the waste ஆகுற time is eliminated. Next, pipeline hazards cannot arise. What is this pipeline hazards? பார்த்தோம் ஞாபகம், what is this pipeline hazard or stall ன்னு சொல்லி பார்த்தோம், or stall hazards ன்னு சொல்லி பார்த்தோம். What is this? That is, what are the stages of pipeline? You'll be having 4 stages. That is fetch, decode, execute and write. So if one instruction is fetching அப்படின்னா another instruction has to wait for the result of the first instruction to execute. கரெக்ட் தானே? ஃபர்ஸ்ட் இன்ஸ்ட்ரக்ஷனோட அவுட்புட் என்னன்னு தெரிஞ்சா மட்டும்தான் செகண்ட் இன்ஸ்ட்ரக்ஷனை எக்ஸிக்யூட் பண்ண முடியும். ஸோ தட் டைப் ஆஃப் ஹசார்ட் இஸ் கால்ட் as pipeline hazard. If you are doing so here, you cannot obtain the pipeline hazard. That is, at each clock cycle, I am keeping on changing the threads. So it need not wait for the data. Next is zero switching overhead. I'll keep switching. Next, then you can hide the throughput losses. That is for short and long stalls. If your stall, that is the waiting period is long அப்படின்னா you'll be having a throughput loss. That is இப்போ நான் பர்ஃபார்மன்ஸ் வந்து எதை டிபெண்ட் பண்ணி இருக்கும், டிபெண்டிங் அப்பான் தி பைப்லைன் அவுட்புட் எவ்ரிதிங் தானே. So that all can be avoided. Next, instruction from the other threads can be executed when one thread stalls up. So what I'll do here, instruction from the other thread, that is output from the other threads can be obtained and executed, because நான் என்ன பண்றேன், I'll keep on changing my threads. Next, its execution efficiency is high. Next, potentially it is less complex than alternative high performance processor. Potentially this is less complex. That is, capability of this is less complex, because here what I'm doing, I'm not changing the processor, I'm changing the thread for each and every clock cycle. Correct தானே? So here I'm not disturbing the performance of my processor. Okay va? What are the disadvantages? That is, the clock cycles are wasted if a thread has little operation to execute. Here clock cycles will be wasted. Clock cycle will be wasted அப்படின்னா இப்போ நான் ஒரு த்ரெட்டை கம்ப்ளீட் பண்றேனோ இல்லையோ, ஐ கீப் ஆன் சேஞ்சிங். புரியுதானே? அப்படிதானம்மா? இப்போ நம்ம இந்த ப்ராசஸ்ல என்ன சொல்றோம், if there is an output or not, I'll keep on change the process அப்படின்னு சொல்றாங்க. இப்போ நான் இப்படி சேஞ்ச் இட் ஆயிட்டே இருக்கப்போ what will be the problem? you will be having a clock cycles wastage. That is ஒரு clock cycle நான் யூஸ் பண்றேன் அப்படின்னா அந்த clock cycle நான் எனக்கு ஒரு அவுட்புட் கிடைச்சிருக்கணும் அப்படிதானே. I'll not get the output at that particular clock cycle. If I'm not getting the particular output at that clock cycle, what I have to do? That is a disadvantage. Next, this is expensive than the coarse grained multithreading. When comparing the fine grained and coarse grained, your fine grained is more expensive. Next, it slows down the execution of individual thread. Since a thread that is ready to execute without a stalls will be delayed by instruction from one thread. That is, இப்போ இந்த பிரச்சனையும் இல்லாம ஸ்டால்ஸ் ப்ராப்ளம் நெக்ஸ்ட் பைப்லைன் ஹசார்ட்ஸ் எதுவுமே இல்லாம you'll be having an instruction, that is you'll be having a thread that will be ready for the execution. But what will happen, what I'll do, I'll change the thread only depending upon the clock cycle. So when I'm changing it depending upon the clock cycle, what will happen there, your execution will get slowed down. பிகாஸ் நான் இந்த கிளாக் சைக்கிள் பண்ணிட்டு இருக்கேன் அப்படின்னு சொன்னா இந்த கிளாக் சைக்கிள் கம்ப்ளீட் ஆகிற வரைக்கும் அது அவுட்புட் வந்தாலும் சரி வராட்டியும் சரி ஐ ஹவ் டு கீப் எக்ஸிக்யூட்டிங் that particular thread alone. So the thread which is ready with all the information is will be waiting. It has to wait. Okay, so other disadvantages. Next, coarse grain multithreading. Coarse grain multithreading is invented as an alternative to this fine grain multithreading. Fine grain oda alternative, instead of fine grain we have designed a new technique that is called as coarse grain multithreading. Okay, this is the version of hardware multithreading and implies the switching between threads only after the significant events, that is such as last level catchiness. That is when it will happen அப்படின்னா only after sorry ma. Okay, in coarse grain multithreading, what we are going to do? This is an alternative for fine grain multithreading. In this, what I'm going to do, I'll a version of hardware multithreading that implies switching between the thread only after the significant events, such as the last level catchiness. That is, இப்போ இந்த எக்ஸிகியூஷன் வந்து இந்த லெவலுக்கு முடிஞ்சா மட்டும்தான் I'll switch the thread. That is the procedure here. ஓகேவா, that is the up till the last level. That is, this execution has to get completed till the last level. Only after it reaches the last level of the execution, your thread will get switched. Correct தானே? அங்க என்ன பண்றோம், என்னோட எக்ஸிகியூஷன் கம்ப்ளீட் ஆயிருக்கோ இல்லையோ, ஃபார் எவ்ரி கிளாக் சைக்கிள் ஐ கீப் ஸ்விட்சிங் தி த்ரெட். பட் ஹியர் இட் இஸ் நாட் லைக் தட். I'll wait until the execution is being completed in a particular clock cycle. After completing only it will get switched. Okay va? This change relieves that the need to have thread switching be extremely fast and is much less like to slow down the execution of an individual thread. That is, நீங்க என்ன பண்ற, சும்மா ஸ்விட்ச் ஆயிட்டே இருக்கிறதுக்கு பதிலா fastly, if I instead of switching the thread fastly, what I'm doing is I'm slowing down the switching and I'm increasing the switch execution time. That is, இப்போ நான் switching வந்து reduce பண்ணேன் அப்படின்னு சொன்னாலே what will happen, the execution of the particular thread will get takes place properly. So this is the process. So from this instruction, other threads will only be issued when a thread encounters a costly stall. ஓகேவா? இப்போ நான் வந்து எப்போ நான் வந்து நெக்ஸ்ட் த்ரெட், when I'm doing a processor, when my processor is doing executing a certain thread அப்படின்னு சொன்னா, it will wait until the thread execution is completed. இல்ல, if there is any issue, okay, that it has to go to the next thread அப்படின்னா, only when it will go அப்படின்னா, that thread is a costly thread. That is depending upon the priority. That is that execution of that thread is very highly prioritized. That is, the priority is very high அப்படின்னா, only then it will go to that execution. Okay, what is this advantage அப்படின்னா, to have a very fast threading switch. That is, இங்க threading switches that will be very fast அப்படின்னு சொல்லி சொல்றாங்க. Next, it does not slow down the thread. This does not slow down the thread. When the thread முடிஞ்சா, it will go for the next step. அவ்வளவுதான். The thread switching is also very fast. Disadvantages: it is hard to overcome the throughput loss from the shorter stalls due to the pipeline startup cost. That is, it is hard to overcome the throughput losses. Whatever the throughput losses I'm having, it is very hard to overcome. So due to the pipeline startup cost. Okay, இப்போ in case this pipeline is not proper, if there isn't any problem in the pipeline stages, whether if it isn't having any problem in the decoding stage, if it is having any problem in the execution stage அப்படின்னு சொன்னா, it is very difficult to overcome because you'll keep on அப்படிதானே, நான் வெயிட் பண்ணிட்டே இருப்பேன் until it execute ஆகுற வரைக்கும். ஸோ அங்க ஏதாவது சேஞ்சஸ் இருக்கு அப்படின்னு சொன்னா, நான் வந்து இதை விட்டுட்டு நெக்ஸ்ட் லெவலுக்கு போகவும் முடியாது. So CPU institutes instruction from one thread. When a stall occurs, the pipeline must be emptied. இப்போ when one thread is getting completed அப்படின்னு சொன்னா, the entire pipeline must be emptied. That entire pipeline must be emptied. Then it has to go for the second instruction. So the new thread must fill the pipeline before instruction can complete. அப்படிதான், புரியுதா? இப்போ நான் ஒரு இன்ஸ்ட்ரக்ஷன் முடிக்க போறேன் அப்படின்னா, before I'm completing that instruction, this pipeline in the stall, I should be having the next instruction. That is, in pipeline it should be present. Okay va? Only then, if this instruction is getting completed, I'll go for the second instruction to process the data. Clear? This is the process. Next, new thread must fill the pipeline before instruction can complete. Due to the startup overload, what will happen? Over coarse grained multithread is much more useful for reducing the penalty of high cost stalls. That is due to the startup overload. And the startup problem இருக்கிறதுனால, this coarse grained multithreading is much more useful for reducing the high cost stalls. That is, here I can reduce the penalty of high cost stalls while pipeline refill is negligible compared to the stall time. That is, pipeline refill. That is, எல்லா பைப்லைனும் ஃபில் ஆகி இருக்கணும் அப்படின்ட்டு, that can be avoided, but it has to be filled. Next, what is the simultaneous multi-threading அப்படின்னா, it is a variation on hardware multi-threading that uses the resources of a multiple issue dynamically. A scheduled pipeline processor. It is a dynamically scheduled pipeline processor to exploit the thread level parallelism. At the same time, it exploits the instruction level parallelism. The parallelism I'm having two types of parallelism. One is an instruction level parallelism, another is a thread level parallelism. What is this instruction and what is this thread level parallelism? அப்படின்னா இப்போ ஒவ்வொரு இன்ஸ்ட்ரக்ஷனையும் நான் எக்ஸிக்யூட் பண்ணேன். ஓகேவா? Resources of multiple issues. I'll be having resources of multiple issues. Dynamically scheduled pipeline processor. Dynamically scheduled pipeline processor to exploit the thread level. Again, a thread level parallelism யூஸ் பண்ணேன். At the same time, it exploits the instruction level parallelism. That is, ஒவ்வொரு த்ரெட்டாவும் நான் வந்து டேட்டாவை ப்ராசஸ் பண்ணிக்கலாம். இல்ல ஆர்எல்ஸ் இன்ஸ்ட்ரக்ஷன் லெவல்லையும் நான் ப்ராசஸ் பண்ணிக்கலாம். What is the difference between instruction and a set? Instruction is a set, that is a complete program, whatever it is there, I'm calling as an instruction. What is this thread abdina? That instruction stream will be divided into small streams. So this instruction and this thread is same. That is, this instruction abdina, I'll be having an entire instruction. In thread, I'll be having the small parts of the instruction. Okay, the key inside that module assembly is that multiple issue processor often have more functional unit parallelism available than the most single threads can effectively use. Okay. What is this simultaneous multi-threading says is, here multiple issue processor. Here I'll be having more functional parallelism available. That is, most single threads can effectively use. இந்த single thread இருக்குல்லையா, அதெல்லாமே நான் இங்க effective யூஸ் பண்றேன்னு சொல்றாங்க. Since SMT relies on the existing dynamic mechanism, it does not switch resources every cycle. For every cycle, it does not keep on switching the resources. Instead, what I'm doing is, here I am executing the instruction from the multiple threads that is associated with the instruction slots and rename the register with their proper threads. According to the requirement, I'll rename and use the processor. Okay. So these are the 4 threads at the top. See, this is your coarse grain, this is fine grain and simultaneous threading. Abdina, I'll simultaneously I'll process the data. That is A, B, P, P, and process பண்ணுவேன். ஆனா இங்க எப்படி கிடையாது. Coarse grainல first A அப்படின்னா only A's will be processed. Next B na B's will be processed. But here in fine grain, A na A, B, C. That is in ABCD முடிச்சிட்டேனா திரும்ப ABCD திரும்ப ABCD அப்படி போவேன். இங்க எப்படி கிடையாது. All the A's will be processed, then all the B's will be processed, all the C will be processed அந்த மாதிரி. But here in simultaneous threading, I'll simultaneously process A instruction B instruction simultaneously mix பண்ணி process பண்ணுவேன். Next BEC, next BA BB அந்த மாதிரி. புரியுதா டிஃபரன்ஸ்? கோர்ஸ் கிரைனுக்கும் ஃபைன் கிரைனுக்கும். கோர்ஸ் கிரைன் அப்படின்னா all the A's will be separated and I'll be processing. ஃபைன் கிரைன் அப்படின்னா ஏ தனியா பிரிப்பேன், உடனே பிஏ தனியா பிரிப்பேன், சிஏ தனியா பிரிப்பேன், டிஏ தனியா பிரிப்பேன். அது ஒரு சைக்கிள். நெக்ஸ்ட் அகைன் ஏ, அகைன் பி, அகைன் சி, அகைன் டி. இந்த சைமல்டேனியஸ் அப்படின்னா ப்ராசஸ் ஏபி, பிசி, சிடி ஆல் திங் வில் பி ப்ராசஸ்டு சைமல்டேனியஸ்லி. கிளியரா? See, this is, you can see in the color which identify. All this black அப்படின்னா this black is all A. This in this அப்படின்னா இதுல blue தனியா. C அப்படின்னா இது தனியா. Thread D அப்படின்னா இது தனியா. எல்லாமே தனித்தனியா. இதுதான் 3 thread. There is thread A, thread B, thread C, and thread D. 4 different colors they are being given for your identification. And it is in coarse threading அப்படின்னு சொன்னா coarse multi-threading. What I'll do, first A will be processed. Next clock cycle, B alone will be processed. Next clock cycle, C will be processed. And the next clock cycle, D will be processed. And it is a fine for in each clock cycle, I'll be having a A, B, C, and D. Clear? 4 color இருக்கு பாத்தியா? A க்கு black இருக்கு, B க்கு dark blue இருக்கு, gray is there, and then light blue is there. Next for the next clock cycle, again black, blue, gray, and white, and sky blue. In each clock cycle, all the 4 threads will be processed. Then the simultaneous multi-thread switching, what I'll do is, here in each clock cycle, I'll be having 2 threads. In the first clock cycle, in the first stage, I'm having A as well as B. Next, I'm having B and C. Next, A, B, and C. A, B, and D. Everything will be processed in the same clock cycle. Okay, this is the process. Okay, what are the advantages? Advantages here is it has the ability to boost utilization by dynamically scheduling functional units among the multiple threads. Here, what I'm having? Dynamically scheduling functional units will be there. among the multiple threads. Next, it increases the hardware design facility. It will increase the hardware design facility, and then this will provide the better performance and add resources to a fine-grained manner. This provides the better performance because I'm using all the threads in a single clock cycle. Next disadvantages is it cannot improve the performance if any shared resources are limiting bottleneck for the performance. That is, இதில் என்ன பிரச்சனை அப்படின்னா when I am executing, when I'm processing the thread A and thread B, if thread B is having any problem அப்படின்னா that process will not get completed. ஏதும் பியும் ரெண்டுமே எக்ஸிக்யூட் பண்ணி அவுட்புட் வந்தா மட்டும்தான் that is an advantage, that is a positive. If B is not obtaining the output அப்படின்னா that is a problem. Clear? Just the disadvantages. What is this multi-core and other shared memory multiprocessor? And this we are going to see what is this multiprocessor. அப்படின்னா the computer system with at least two processor. With at least two processor, that is called as multiprocessor. More than two processor, இல்ல more than one processor, that is it can be a two processor, three processor. That's not a problem. If it is having more than one processor, I call it as a, what I'm calling as a multiprocessor. What is this multi-core? More than one processor available within a single chip. ஒரே chipல என்ன having more than one processor and calling it as a multi-core. The conventional multiprocessor system is commonly referred as shared memory multiprocessor system. What is this I'm calling? It is called as conventional multiprocessor system is commonly referred as a shared memory. It is a shared memory multiprocessor system I am saying. That is how I am doing this. Then I'll be having a memory and having an input-output device. This is an interconnection network, and I'll be having a cache as well as processor. This is a cache is a temporary storage, and this is a secondary memory. This memory is a primary memory, and then this cache and this processor all will be sharing the same input and output device as well as memory. That is called as shared memory multiprocessor. That is, I'm having a memory. This will act as a primary memory. All the data is present, all the data whatever given as an input will be stored in this memory only. When the processor A, that is this processor A is processing அப்படின்னா the data required for this processor will be temporarily stored in this cache memory. So this processor will obtain the data from this cache memory. So data for this cache memory will be from this memory. So the data from this memory will be obtained by this intermediate caches, and then appropriate processor will obtain the data from that particular cache. Okay, ma? This is called as, what I'm saying, this is called as shared memory multiprocessor. Okay. So now all the processor can communicate through the shared variables in memory with all the processors capable of accessing any memory location. It can access any memory location via load and store. Next, systems can still run independent jobs in their own virtual address space. On its own virtual address space, it can do the process. Even if they all share physical address space, if they are all sharing the same physical address space, own virtual space can be allocated and you can use this. Next, the use of a shared data must be coordinated by the synchronization primitive locks that allows access of data to one processor at a time. Okay, what I'm doing is your data, whatever is given as input, that what I'll do, it has to be synchronized properly. That is, at a time, all the processor can use that particular data and and the processor can be processed at a time. What is this multiprocessor? It is a shared memory processor. This multiprocessor is two types. It is the shared memory processor one. Another one is a distributed memory processor. In shared memory processor, that is a tightly coupled, that shared memory processor is also called as tightly coupled processor, and the distributed memory processor is called as loosely coupled processor. Multiprocessor is divided into two types. One is a shared memory, another one is a distributed memory. This shared memory I'm calling as it can also be called as tightly coupled processor. This distributed memory processor is also called as loosely shared processor. Okay, va? Then this shared memory processor is again divided into two types. There is an uniform memory access, another one is a non-uniform memory access. One is a uniform memory access, another one is a non-uniform memory access. Next, then this loosely coupled, I'm calling it as a cluster. So, okay, va? Okay, you can leave now and join tomorrow. Thank you.